because we won't have any lesson at 3 or 4.
We didn't agree on that. We weren't informed
Right.
about this yesterday.
Yes, that's because
We made plans.
I know. That's because
So we
I was supposed to tell you only this morning. What difference does it make? What plans
No,
did
so
you
we're
make?
having 2 lessons now?
And one later.
So 3 lessons?
Yeah, but not at the same time. So relax.
Yeah.
Why is the lesson later? Math or physics?
I will be generous and I'll let you choose between the two.
Oh.
We're doing physics now?
Yes.
Oh,
Okay,
that
let's
will.
do the next one, math. So that we're doing one from each?
You want to go physics, maths, physics?
Yeah. So that we don't miss a lot. And we're skipping. That
Okay. I think I can do that. Anyway, so to continue
So
with...
is this a double or what?
Huh?
Is this a physics double?
This is physics class.
Or
I'm
what?
con-
At 10 A?
Huh?
At 10 later.
What?
Later at 10 we will have physics or math.
Oh, he wants to have maths at 10. We're only on the first lesson of fields, aren't we?
Yeah.
Electric fields, okay. Okay. I have to continue with some examples.
You might want to confirm with him.
No,
I was sleeping.
I think it's true.
Me?
Yeah, no,
Never mind.
it's okay.
No.
Huh? Okay. We did this one with the 3 protons, didn't we? I think the next one is this. So I'm going to do this one, but I'd like you to either draw or write it down.
Do you like my raincoat?
It's alright.
Or the bag? It's not so much.
Good you have your priorities right.
I can get it. Sorry, I want more attention.
Wow. What happened to you?
Brain works.
I'd expect that from Lee, but not from you. Alright, let's have a look now at this one. So, here
Put my thing there.
you have a dust particle, and its mass is 1 milligram. Yes, which is 10 to the minus 9 kilograms. And it's held between 2 plates where there's an electric field. And the charge of it is negative. Now, what's wrong, Lee?
Thank you.
What? What's going on?
No, Chinese week.
Steven, why can't I find
Hang on. Sorry, I'm being distracted. Thank you.
Six?
Yes.
Is it 3?
Honey?
Yeah, but I wanted. But kilo is 10 to the 3. So 10 to the 3 by 10 to the minus 6 is 10 to the minus 3.
Nice.
Now here the field is going down in the picture. So, maybe someone can tell me, if the field is pointing down, then why am I drawing the force from the field pointing up? No, it's continuing from the last lesson.
Because it's a negative part.
Yeah, because it's negative, yeah. There's one other force I'm missing in this picture. What is it?
Thrust of the...
No. I have the thrust, so to speak, already here. Gravity, yeah. So there's a downward force here. So in the question, I say it's not moving. So that means the force going up should equal the force going down. The force going up, we can get that from the formula QE. Yes? That's what we did yesterday. And what's the force going down? mg. The Q, I said, is 100 E. There's 100 electrons on it. The E, I think I give it to you. Or do I? No, the E is actually what I want. The M is 10 to the minus 6 and the G is 9.81. So if I just divide, I have this here. Does anyone have the Casio calculator? You have the E constant, number 23, isn't it?
Yes. Shift 07.
Yeah. So can you hit this in?
What's the number? 27?
23.
Oops. Shift constant 23. What? It says RE, not E.
No, it's A by you.
Oh, nice.
That's good one.
Oh, nicer. 9.81 exponent negative 6 and it's 100 6.12 times 10 to the power 11.
Newtons per coulomb.
Question.
Yeah.
When I did this, we used to get it as E energy or as electron volts.
No, I think you're thinking of something else, which we'll be doing later in this chapter. Electron volts and joules and all that. Yeah.
Joules, sorry.
No, you're mixing that up with something else. This is definitely the correct unit, newtons per coulomb.
Newton
Huh?
per coulomb.
Isn't it? For electric field strength? Isn't that the unit? Newtons per coulomb? Don't mess with me, man. Alright, can you write this one down and then we'll do the next example? Yeah, exactly.
Leave this with it.
You wrote this down?
Will we do the hand rules?
Yes.
I don't like
Fleming's left hand rule.
left hand side.
Yeah. Left hand rule, right hand rule,
Other group.
and the grip rule too.
Grip rules.
Okay. Come on, chop chop.
If someone forgot their chemistry book back,
They don't tell anyone about it and they go and spend a new one.
I hope for the best.
is it possible to buy a new one?
Of course. You can use a website called Amazon. Have you heard of them before?
No, the
No.
chemistry notes.
She did it
that's
herself.
already-
Oh, the nodes. The
That's what
nodes.
I'm saying, just scan it yourself. Unless you want to see Dr. Lorraine.
What, angry? That never happens. You could ask her nicely to reprint it. Does she like you?
Don't.
Do you give her a hard time?
Don't ask.
Some people shouldn't ask. Some people might be okay.
No, if anyone would ask, where did you lose it? How did you lose it? You're irresponsible. You don't take care of your chemistry class.
That, you might not say that to everyone.
No, trust me.
Trust you? Well, there's only one way to find out. You'll have to ask. Okay, did you write this down?
It would be expensive.
To print?
FedEx.
Just get it posted, regular post.
How long would it take?
Where's it coming from?
Dubai.
It'll take like 2 weeks, shouldn't it?
That's what you think. Regular post is not by plane, it's by ship, so it'll take a month.
Wait, what?
Yeah.
To buy send stuff by ship?
Yeah, that's why I said better.
Yeah, okay.
The more you get, that's the
Ship, my goodness. Ship. Okay. Next example now. The next example, let's see, yeah. A proton and another proton are fixed a certain distance apart. What is the field strength at the point which is equidistant between their centers? So, you've got a proton here, and I want to know how strong the field is at the center here. Who knows the answer?
Proton.
Yeah.
And then
So the charge here, E.
yeah.
Charge here, E. Distance, I don't give you. You can call this distance if you like, D.
It doesn't move, stays the same.
Yeah, so what's the electric field strength?
Oh, 0.
Yeah. Because remember, electric field strength is force over charge, which is 0 over charge. Why does it not move here? Why is there no force here?
Because the forces are equal on both sides.
Yeah, there's no net force.
Why is the dot?
The dot?
Yeah.
That's the small positive charge where we calculate the field strength. So I said in the question, what is the field strength when you're equal distance from two protons here in the center? And the answer is there is no field, really, because they cancel at the center. There's no force. And the formula, if you remember, is force over charge, and if there's no force, then there's no electric field strength.
Is that how we present an electron?
No, there is no electron here, they're all protons. Plus.
So what's the E for?
Oh, that's its charge. That's on your calculator. It's a constant. It's okay, Lee? Yeah. Continue. So we'll do the tutorial now, and I think what we'll do is we'll alternate. There's only 4 questions, so we'll just take turns doing them. And I think the first 1, 2, maybe even 3 are very easy, so it won't take us that long. Can I continue? Yeah. Okay, so let's have a look at the questions here. Well, the first one is really easy. We'll do that one together to get started. If the charge is doubled, then what happens to the force? So you have a charge that's in an electric field, and the charge doubles from Q to 2Q. What happens to the force? It doubles as well. Why? What's the formula for the force? QE. So, yeah, if you double the charge, then you double the force. As simple as that. Okay, that's the first one done. I want you to try the second one before I do it, please.
We change it to kilograms.
Oh yes. What is 1 microgram in kilograms, please?
1 times 10 to the power -9.
Correct.
Yeah, because micro is
One hour.
-6 and gram to kilogram is -3. equals MA.
G equals MA.
No, F equals MG.
F equals mg, true. But not well. It's not the total force. F.
Yeah.
No, because there's two forces acting on it, so mg is not enough.
Since it's QE.
Yeah, there should be a QE somewhere in there. Now it's not QE equals mg because it's not balanced. It's accelerating. It's not quite like the example I did because it is falling. In fact, I give you the information to tell you it's accelerating from rest to over a 1 centimeter distance in 1 second.
Okay, got it. If you want the F.
E.
I want the E, electric field strength.
So
Okay.
QE equals MA.
Closer. But now you forgot about the mg.
Yeah.
Well,
You
yeah.
have the M and the G, so we have to use it.
You look confused.
Do we know the field strength?
That's the blooming question. What is the
Wait,
electric
wait,
field
wait.
strength?
The electric strength, the field strength is E.
Yeah.
What's F?
The force.
What force?
Which F are we talking about? In MA?
In question 2.
There are two forces. mg and QE. No, like this. Because
Certainly.
do you know, fair enough, Lee, I didn't actually use the verb falls, but I should have. It's fallen. Oh, sorry. I apologise. I was looking at the wrong question, number 3. I'm so sorry. Number 2. I'm totally wrong, so sorry. Number 2, Lee's right. It's not fallen. I was looking at a different question. It's moving towards something. So if you prefer, you can think about it moving horizontally. So you need the mass, not because you need to know mg, because it's not falling, but because you need to know the m in the F equals ma. Yeah. So I'm sorry, I think earlier someone might have said what you have to do.
F equals MA.
F equals ma, which equals QE. Yeah. So you're right, ma equals QE. That will give you it then.
So no
Stay
MG.
with me.
No mg, I'm so sorry. I'm so sorry, I'm so sorry. So now it should be much, much easier. See, your English is quite good.
Okay, that's shoot to me.
Yeah.
Only a messenger.
Yeah.
What's the acceleration? We have the distance and we have the time.
Yeah. You have the U, T, and the S.
Just give us acceleration. Is why you're taking it back to Newton's laws.
Because that's how I roll.
You roll like this.
I do roll like this. Or more importantly, that's how the exam rolls. The September students didn't do great in their exams. I corrected it. They didn't do great.
Correct.
Like terrible.
Huh?
Terrible.
Turbo bad. Well, there were only 4 September students, so.
Not good news, I guess.
No, honestly, I think our class is better than their class.
I would never say such a thing publicly, especially when anything is being recorded. But I still sometimes worry a little bit about this class. No, I think I should worry a little bit. For some people at least. Yeah. Alright, do we have an answer here for 2?
Do Newton find acceleration and big answer.
Give me acceleration, please.
We don't know V.
Yes, Lee. So we have Lee. What's the U? 0. V? No, we don't know. Well, yeah. A? Don't know. T? 1. S? 0.01. And I'd like the A. So what could I use? Yeah. S equals UT plus a half AT squared. So that's 0. And the T is 1.
Whoa.
And the S is 0.01 equals a half A. So A is 0.02 meters per second squared. Now, the particle has one force acting on it, which is from the electric field, which is QE. And the E then will equal MA over Q. We know what the mass is, don't we? We said it's a microgram?
Yes.
1 times 10.
So 10 to the minus 9
Yeah.
times 0.02. And what did I say the charge was?
10 to the 0, to the negative.
I said it was a millicoulomb, was it?
Yeah.
Alright, so I don't need a calculator here because this will be 10 to the minus 6 times 2 times 10 to the minus 2, right?
1 over
Which is
50
2
million
times 10 to
thousand.
the minus 8. What?
1 over 50 million thousand.
Yeah, but if we write it the usual way, we get this. Newtons per coulomb. Which is 20 nanonewtons per coulomb. Yes. Good, no problem. Super. Now, number 3 is what I was thinking about a moment ago. The dust falls from one plate to a lower plate. Getting more interesting, huh?
Still no Newton.
What have you got against Newton?
It's like never did, never.
The field.
It gives
You
you
can work.
negative 200.
No, you can work out the direction because how long did it take to fall 10 centimeters?
That's it.
So which, don't say it, Lee, just show me with your hand. Which way is the field? Which way, Lee? I think you know, Faisal knows. The field
10
is,
centimeters. 10 seconds.
the field,
10 centimeters.
it doesn't really matter which way the field is pointing, you just need to care about which way the force is pointing, really, and which way is the force pointing from the field. It must be upwards, because it has to be slowing the particle down, because it cannot take 10 seconds to fall 10 centimeters. So as the particle falls, the force from the field must be pointing up on the particle. Will it be bigger, smaller, or equal to the downward force?
Small.
Bigger.
Smaller, because if it was bigger, then the particle would be rising.
Oh.
So it's big, but not big enough to stop the particle, yeah. Just to slow it down in its fall. Okay, now that you understand that, I think you can do it. And yes, we'll need Newton again.
Just like a magnet. Just sitting on.
It is a bit like it, yeah, and the upward forces slowing the descent down.
Imagine, this takes 10 seconds. Support this. 10 seconds ago. Not this.
Yeah, we get it. I tried.
10 seconds. Oh, I wanted to ask. Is the gravity on an
Yeah.
object
Zero.
affected by the mass of the object?
The
Isn't
gravity on the object? Now, use a different preposition. I don't know what you mean.
the gravity between two objects.
Yes,
Yes, but this answers the question. Then yeah, they are affected by the mass of the
yes.
object. So, what I was thinking, like a wood or like a metal piece of this and this plastic, they will not have the same gravity with the earth.
The metal and the plastic,
Yeah.
are they the same mass?
No, they're not.
Then they will not have the same
Yeah.
gravity force.
Okay, so in physics, when we're solving for everything, why do we use gravity as a constant?
But we don't say the acceleration due to gravity is a constant, not the force.
But doesn't the acceleration differs according to the gravity? Mind blown.
This is mass.
Yes.
What is the force?
MA.
Yeah, ma, or in other words, mg.
Yes.
Now, the m's cancel, so the a is always g,
Yes.
regardless of the m. But the force is different. You can change the force by changing the mass.
Yes.
Look, F equals ma, but F equals mg.
Yes.
So ma equals mg.
Yes.
So a is always g.
Yes.
Always, regardless of the m. You can change the m to change the force, but you cannot change the g.
Yeah, so the acceleration due to gravity is always the same, regardless of the object.
Mass.
The mass of the object, yeah.
Yes. The only time it's not is when you're not allowed to cancel the m's here, which happens when m is 0. So as long as the mass is not 0, the acceleration is g. The mass is 0, and the acceleration is 0. Because there isn't anything to accelerate. How are we doing with number 3 here? Lee, you have an answer?
Give me the acceleration, the answer.
Give me the acceleration, Lee, and I'll solve it, please.
Please. Yeah.
He's not your Newton calculator.
It's better than it's the one and the only.
Yes, that is true. He's quite unique.
Lee.
Yeah,
There's only one Lee in this world.
and that's enough.
7 other million.
Probably it's a billion.
Yeah, probably.
No, there's no one quite like Lee. Lee special.
Lee.
Get an answer, Lee?
I don't follow.
I think it should be quite big. How big is big? Pretty big. Yeah, let's have a look at it now. Okay, so as I was discussing earlier, because it takes so long to fall between the two plates, the force from the field must be acting up. And what is the formula for this force? QE. And what force is acting down?
MG.
And which is bigger?
MG.
So in total it moves down. Okay? And there's a force F is the total force. So the total force down is mg minus QE. Yeah? This number here will be pretty small, because the QE nearly cancels the mg because it moves quite slow. So this here I think will be quite small. But Newton said F is ma, So we end up with this. Now what am I looking for here? I'm looking for the E again. So I can say QE equals mg minus ma. So E is equal to m over q g minus a. So as soon as I have the A, I'm finished. The U is 0. The V I don't know, the A I don't know, the T is 10 and the S is 0.10. And we'll go with S equals UT plus a half A T squared. So that means 0.10 equals 50A. So A is 0.10 over 50, which is 1 over 500, isn't it? So the answer is M. What's the M here? 2 milligrams. The Q, what's the Q? It's 200E. The G is 9.81 and the A is 1 over 500. So let's see what we get here. What was the constant number for E? 23?
Yes, this is what I was saying. What is the unit of E?
Newtons per coulomb.
This small e.
Oh, that E!
Yes.
Oh, that is coulombs.
Yeah, so what I was saying is I'm multiplying the E with its constant so that we're getting the final answer.
What? I don't know what you're saying.
What we used to do is get the answer in E and then multiply it by the constant.
That's when we're using electron volts, which we haven't studied yet.
Yeah, that's okay.
Yes.
This is the same electron volts.
Nearly. There's a small difference. Nearly.
Could you go to there, on the left?
Oh, here. This part. That's just me using UVATS to get the A. So I tell you in the question the U is 0, the T is 10, and the S is 0.10.
So I thought it was a Q.
That's an A.
Yeah.
Is it okay, Lee? This is the answer you got. Yeah. Okay, one more question here. It's getting trickier. Can I continue? Yes? Right, now we're getting juicy. One electron orbits one proton. By the way, what is one electron around one proton? What atom is that?
Hydrogen.
Hydrogen.
Question.
No, wait, I'm in the literally in the middle of something. One electron orbits one proton. That is a hydrogen. The radius of the orbit is 10 to the minus 10 meters. And the strength of the electric field at the electron's location is 1.4 times 10 to the minus 10 newtons per coulomb. What is the periodic time? It's a tricksy one, for sure. But it is something you can get in the exam. A difficult one for the exam, but certainly an exam question. You'll have to think carefully about this. Now, what was your question?
I got a negative 6.12.
That's because you put in minus 200.
Yeah.
But I already considered the minus by putting the minus in my formula by subtracting the 2.
Yeah, I did subtract the 2.
Yeah, but you're putting in minus twice, is my point. The sign, listen, the sign is only to indicate the direction.
Yeah.
So if you keep minus in the value of it, then you're adding the forces together. Okay, anyways, try number 4. Come on, you can do it.
Yeah. I don't remember the formula for the T.
Well, good thing I like to throw in a bit of Newton revision to my questions, huh? FIFO. Good old Google, it'll give you the answer. Nobody remembers their formulas. You are a disgrace.
Oh, you have them in the formula booklet.
Yeah.
You should know them. It looks like the E is stuck. You stuck? Or you can do it? You're stuck? What is stuck? It means you can't do it. Okay.
Who's that from?
I don't know where Fuang is. She might have something to do with Sylvia. Andrew, I'm sure, is asleep.
Oh, I see.
Did she message you?
Yeah.
What did she say?
She's on the muscle now.
She was asleep. What about you, Steph?
This is beautiful WhatsApp.
Oh, disgraceful.
Oh yeah, I know why. Because they probably sleep late. Their days late, kind of. Because they need to eat before sunrise.
So what's Fuang's excuse then? She's secretly a Muslim and
I'm
not
here.
Catholic anymore.
I'm here, I'm doing the same.
Yeah, I stopped late.
Yeah, but you're quite unique.
Of course.
Yes, way too much energy.
No, because I
Wake
sleep
up,
during the day.
I need to walk.
Yeah.
I sleep enough at night.
Yeah, quick power nap in maths class has him going for the rest of the day.
In the gym. Okay, we use the circular
Correct.
function thingies.
Yes.
We don't know the velocity, so we don't know the circular velocity. Wait, but I remember this one question I asked you. That question is the answer, but I can't still remember it. We use rate the angle at 360 because it's a point.
Oh no, not this.
But we only know the radius.
You know I love these questions when it seems like you don't know enough. They're my favourite. But you know deep down, I did give you enough. I must have.
Is it the one under the square root?
There's the square root and the square in there, yeah. You do need squares. You will need to use a square root, I'm sure, because there are squares in the formula.
Wait.
Is it a very long formula?
No, very.
Not very long. There's a square root, there's a G, there's a L, this is
An L?
okay, a long formula.
I think so.
Or are you talking about LG? L over G.
Yeah, L.
Oh, no. What answer did you get? Seems believable. Let's see if you're right. Okay,
Please don't give up.
No.
let's have a look here. Photon, electron, radius, 10 to the minus 10 meters. Electric field strength, 1.4 times 10 to the minus 10 newtons per coulomb. That is all you know. Okay. What type of motion is this? Circular. There's an inward circular force here, and the formula for that is m omega squared or. However, what is causing this force? The field. And what's the formula for the force for a field? QE. That means that m omega squared or equals QE. So that means omega is square root QE over MR. Yes? So that means 1 over omega is root MR over QE. Yes? That means 2 pi over omega is 2 pi root MR over QP. What's 2 pi over omega? Anyone remember that formula?
This is
T.
actually- Oh, oops.
So I have the answer. It's this. Let's calculate. 2 pi. What electron, isn't it? Is that constant true? Yeah. The radius, the charge of an electron, and the electric field strength. And the answer is not Lee's answer. Sorry, Lee.
What's the M?
Huh? Mass of electron.
What's the value?
Huh? The answer is 12.7.
No,
Can you
same problem. The same position.
Hang on, let me think. -6 is 4 seconds. You got a different number? But I used the formula there. Did I use it right? M or Q E 2 pi.
Most of the electron are 9.11 times 10⁻³
I think so. Here, I'll check it for you. Mass of electron. I don't think I made a mistake. Interesting. We have 2 different answers.
Can you go back to the question, please?
Yeah.
Because how do we get N equal M omega square?
Dude, that's the formula for force when something's moving in a circle.
Really?
Yeah, really? You forgot that, huh?
What is E?
Which is small e,
No, big E.
electric field strength.
Yeah.
So,
Can you explain the last step, like how did you add the 2 and the 2 pi over the omega? Like how did you combine the formulas?
what I did was, next thing I did was I flipped the left and the right.
Okay.
So I had 1 over pi omega equals this upside down.
Oh.
And then what I did was I multiplied both sides by 2 pi. Because 2 pi over omega is T.
Do we know Q?
If an electron, so we do.
Which is?
Constant 23.
And M is constant 3?
Yes.
No.
Thank you.
Very high.
If, oddly.
Back to the question.
Back to the question, please.
Radius is 10.
How do you know the big?
No, it's just minus.
Because I give it to you.
Is it like Q?
No. That is the strength of the electric field.
Whoa, what was your answer? Whoa!
Yeah, very close.
Okay, look at
78,000.
You know how do you find Q?
You don't. You know it's an electron.
This one. On the left.
Oh.
This one.
Yeah.
How'd you get the A? 2 times 10 to the minus 3.
A is, I made it EQ equals to mg.
Oh no. Wait, this is question 2.
No, last one.
Where?
No.
Where does it start? Oh, here.
The bottom was this. A equals this.
A equals this. Does it?
Circular motion, yeah. Got
Does
this
it?
from Google. Circular acceleration.
That's only if the mass is 1.
Really?
Mm. 'Cause what's
No,
it-
no, this is not 1, this is R, sorry.
Oh!
Amplitude 2 pi over time period.
You have the formula A equals... You basically said A... This is or.
Yeah,
Or
this is the
omega
amplitude.
squared.
Yeah. Yeah, this is what I used.
Yeah, because you can then say MA equals M omega squared or F equals M omega squared or, which is the same formula as me, so I'm happy with that. So what did you do? You divided by or.
No, I moved the R
Yes.
and then I took roots on both sides.
Let me speak. You divided by or,
Yes.
and you square root both sides,
Yeah.
so that's gone, so you have this.
Mhm.
So T is root A over or over 2 pi.
Yeah.
Okay, good.
Yeah.
So then the question is, you know this, but what's this? And how'd you get that?
MA equals EQ.
MA equals EQ.
Is this right?
It is.
Yeah, this is what I did.
So,
Yeah, this is what I did. So you have an answer. We have
But
an
wait.
answer. And do you think what I did was right?
But what's this on the top though?
This is the EQ over M.
So where's the E? And where's the Q?
This is the E. This is the Q.
What? It should be E multiplied by Q.
Yeah. Yeah, I wrote it QE.
Oh, okay. Well, I'm just not happy with how that's typed because I just feel like your calculator might freak out by not having brackets here. I'm going to put brackets here and see if that changes the answer, okay? That's the 1.4 times 10 to the minus 10 times E over ME. Interesting. And then what's this over? Or.
This is the R, yeah.
And then that's rooted over 2 pi.
Yeah.
And blah, blah. Well, come on in. I don't know, Faisal. I feel like we should give you the same answer, but I don't know. I don't like using
Is
this.
right? That I'm making MA equals to EQ.
Yeah.
So they both have the same force.
Yes. MA must equal EQ.
Okay. Lee, what was your answer?
Yeah, I want to see the calculator.
Look.
You're correct.
He has a different calculator.
I don't like this 10 button here. It's a mystery, Faisal.
12.2.
That's
He has 12.2. Maybe you have a decimal point mistake.
Ah.
Yeah.
Upside down, dude.
No, but wait.
Dude, it's upside down. When I got the look,
I saw this.
Come on, out.
No.
You're here for the second class. Sit.
Huh?
Read and sit.
That's a stupid mistake.
Sit. Sit.
But I'm happy what I did was right.
Yes. Except when it was wrong. Okay. So,
Things like this make me lose marks.
second class we'll do some maths. We have two classes now. And then we have a class at 1 o'clock. We do. But the good news is then you're finished at 2 o'clock and you can go home and sleep until pizza time.
What do you guys want?
What?
Do you want to have physics now or math now?
Physics.
You want to continue with physics?
And then the last lesson will be math.
Yes.
Okay.
Physics or maths?
She's late.
Doesn't matter.
Physics or maths?
No. He took the lesson.
You don't care. Physics or maths?
Chemistry and then
What you want?
math.
Physics. What do you want now and what do you want later?
Do you want to have physics now and math later or math now or physics?
Physics now then. Physics now. Okay, we'll continue then. Let me close this.